the power 3c. But e to the power 3c is a constant. I call it k. That implies that I can make any subject of the formula. Y cubed is what? It's k into x cubed. That's what. But what are we given? We are given that y is equal to what? Y is equal to 2 when x is 1. The matter of substituting here. Sorry. Y is equal to 2 when x is 1. Therefore, then 2 cubed is k, x is 1. It's 1 cubed plus 1. This is what? It's 2k. That is 2k. Therefore, what is that? This is 8 over 2. This is 8 divided by 2, give us k. Therefore, k is what? It's 4. Therefore, your answer is now is y cubed is what? It's 4 into x cubed plus 1. And this is your answer. Okay. We are still separating variables. Please indicate if you are not sure. We try this one again. Cos x plus sin x dy plus cos x minus sin x dx is equal to 0. We separate variables. All terms with x on dx. You can see that this term here, the whole of that is dy, so we don't need it here. So you can divide by the whole lot. Therefore, dy plus cos x minus sin x. There is the term that I'm dividing with. Then it joins here. Divide by what? Cos x plus sin x bracket dx is equal to 0. Transpose, if you like, then a column transpose a column, it doesn't matter. That becomes integral cos x minus sin x all over what? Cos x plus sin x dx. Integrate both sides. This implies that y is equal to 2. Now, what is the relationship between the denominator as well as the numerator? If I pull out my denominator as this, what is its derivative? Its derivative is minus sin x cos x. So it directly gives me what I have on top. My f at x is cos x plus sin x. What is f prime x? It is minus sin x plus cos x. And this term here, this whole term is that. Okay, so my answer, if that is the case, is minus ln of the denominator, cos x plus sin x. Now, you know how to treat that, of course, constant c. There's some constant c. Now, I can play around with this now. I can transpose by c and be left with minus ln of cos x plus what? Plus sin x. If I divide by minus, I'll get c minus y. Divide by minus. I'll get c minus y is ln of what? Of cos x plus what? Plus sin x. Get rid of a log. Therefore, a to the power c minus y is what? Is cos x plus what? Plus sin x. If I split that, this is a to the power c, e to the power minus y is equal to cos x plus sin x. But this on its own, that is a constant. I call it what? K. e to the power minus y is equal to cos x plus sin x. Now, if you want to make k the subject of the formula, that is k is equal, this is e to the power, it will end up being e to the power y into what? Into cos x plus what? Plus sin x. And this is your answer. Are we okay?
Yes, sir.
Sure. What happened to my screen now? Okay. Right. Let us see whether we can find another one. We are still on separating variables. Let's try this one. 4 1 plus 2y dx plus 4 minus x squared dy equals to 0. Right, where do we start? Perhaps to be clear, let us transpose 1 on the other side. So 1 plus 2y bracket dx is the same as minus 4 minus x squared dy. That is allowed. Now, this 4 minus x squared is not in the right place here because there is dy. And this one again here is not in the right place because there's dx here. I divide by that and divide by that. So I'll end up with what? With dx over what? Over 4 minus x squared. I left that minus there. Minus dy over what? 1 plus 2y. Right? Oh, wait. I did not realize that this will need us to use partial fractions. But let's go through that anyway. Now, there's nothing wrong with the left-hand side. I mean, with this side here. I can easily integrate them. The problem is here. This, I must first apply partial fractions. Right. I'll just consider the right-hand side, left-hand side, sorry. Left-hand side, I'll exhaust it and then I'll come back. So that is 1 over 2 minus x into what? 2 plus x, because there's a difference of 2 squares, of which the format is a over 2 minus x plus b over 2 plus x by partial fractions. I just left that. I'm still working the left-hand side only. That becomes 1 is equals to a into x plus 2 or 2 plus x plus b into what? Into 2 minus x. 0. Let x be what? Be 2. When x is 2, that will be 0. But here I'll get 4a. Therefore, my a here is 1 over 4. Let x be minus 2. Then I will have y equals to x is minus 2. This will be 0. X is minus 2. That will be minus 4 what? B. In which case, my b is what? It's minus 1 over 4. Then, therefore, let's go back now. We know the format. Therefore, the integral, then we start going manje. Therefore, the integral a 1 over 4. 1 over 4 out dx. My a was over 2 minus x. 2 minus x plus b. B is minus, sorry. Minus this one. Minus 1 over 4 integral dx over what? Over 2 plus x or x plus 2. X plus 2 equals to, I bring back the one that I dropped, integral dy over 1 plus 2y. Now, what is the integral of this? The integral of this here, if I take this one to be my f at x and differentiate, I'll get minus. So I need a minus there. So that will be minus 1 over 4. What? Ln of 2 minus x. Now, if I differentiate this, I'll get 1. There's nothing wrong with that. So that will remain as minus 4. As minus 4. What? Ln of x plus 2 equals 2. But here, if I differentiate this, I'll get 2. I need a 2 there, and then I must take half. Right? Therefore, the answer is minus half. What? Ln of 1 plus what? Plus 2y. Now you can say minus, minus, minus. I can divide by minus, or I can multiply by minus 4 throughout. If I multiply by minus 4, as the LCD, multiply by minus 4 throughout, I will get what? Ln of 2 minus x plus ln of what? Of x plus 2 equals 2. I multiply by minus 4. That will be what? That will be 2 ln of that, which is the same as ln of 1 plus 2y index 2. Okay? There's 2 in front here. I can take it on top. This is the same as ln of what? Of 2 minus x into what? Into x plus 2. Close that. Equals to ln of 1 plus 2y all squared. Ln A is equal to ln B. That is, we can easily say 2 minus x into what? Into x plus 2 is equal to 1 plus 2y what? All squared. And this is the answer. Okay. But I think I lost track of a constant here when I was integrating. You can put it plus C plus C plus C, and then you can play around with it. But that is the idea behind. Okay. Right. Perhaps we look at the next set. I think linear differential equations. Linear differential equations. Just remind ourselves about the format. All linear differential equation will take this shape: dy over dx plus p times y give us q, some function of x, where p and q are constant. Now, to solve, we first find an integrating factor. An integrating what? Factor, which I usually abbreviated as IF, which is given by what? A to the power of the integral of p dx. Now, how to solve it? Then the solution will always be y times your integrating factor equals to the integral of q as a function of x times your integrating factor, what? Dx. So all linear differential equation will have a solution given by that, depending, of course, here, whether you had y. If you had I here, it will be I times IF, e.g. dy over dx plus y cot of x is equal to what? Cos x. Now, if you look at this differential equation here, it appears to be linear in the sense that it's linear in the sense that there is y here, there is y from our general case, there is p here, which is cot x, and this one is q. So we are seeing that p is what? Is cot x, and what? Q is what? Is cos x. Right. Therefore, what is what? So the integral of P, which is cot x dx, is what is cot? It is cos x over what? Over sine x. So derivative there, is this related to that? Yes. The answer here is ln what? Ln sine x. Therefore, don't forget your integrating factor is E ln sine x, which is nothing else but what? But sine x. Remember how to treat logs. Therefore, what is the solution? Hence, general solution is y times if is equals to integral q times if what? Dx. This becomes, that is y times if is what? Is sine x is equals to the integral of q. Our q there was cos x. Our if was what? Was sine x what? Dx. Question is, can we integrate that? That should be relatively very easy. Are these two related? Remember, integral f prime x, f at x to the power n dx is f at x to the power n plus 1 over n plus 1 plus c. So that's max 1. So if I differentiate this, it will give me that. So this is this case here. Right. So if I differentiate that one, it directly gives me that. So the answer is given by sine x. This was to the power 1. 1 plus 1 over 2. That is 2 plus 2 plus c. Y what? Y sine. This gives us y then is equal to divide by sine x, if you like. So it's going to be sine x over 2 plus c sine x, which you can write as sine x over 2. This is 1 over sine x, which is just cosec. Cosec x. And this is the answer. So far, so good. Right? Anyone who is having a problem, because I've asked you to bring problems, not me giving you problems.
Sorry, sir.
Anyone need a question?
Sorry, sir.
Yes.
Angigconyiwe kancane sir, ayi-confusion iningi la usanda kuphuma khona sir. La sir, angithi sesazi ukuthi nje sir uma integrate u-cos ikhona indlela yakhona, uma integrate u-sin ikhona indlela yakhona. Manje
Yes.
lento enza la sir angi-understand.
Ubani?
Qhamuka la eceleni to the right, la nje la uzwa
Gebla?
lapho soda yaka-right la
La?
phezulu sekwakhona.
Right.
Yes,
Okay,
phezulu yes.
Okay, what I've done here, uyabona la kuno cos x no sin x, eh? So
Yes,
ngibheke u-sin x, ngathi if ngidifferentiate u-sin x, inginikeza lokhu. Angithi? Ngase ngikwa-maths 1, safundisa ukuthi if you have got your f at x here and your derivative is this one, so your answer is given by your f at x to the power n plus 1 over n plus 1. Ukube ngithanda bengathi futhi, for this particular problem, it works both ways. Or bengathi, or y sine x is the integral of cos x what sine x dx. First of all, I looked at that. Now I can also look at that. The derivative of if I take this as my f at x is what? Is cos x. But what is its derivative? Is what? It's minus sine x. Sine x ukhona nami. Engenaba minus. I can play around, put a minus there and take a minus there. Then my answer will be minus that, minus cos x to the power n plus 1, which is 2 over 2 plus what? Plus c y sine x. That is also my answer. Divide by sine, y is equal to minus bracket cos x all squared over what? 2 what? Sine x, if you like, plus what? 2 over what? Over sine x. This is also answer. This answer and that answer is one and the same thing for this particular problem. Okay, so mina ngikubheka ukuthi ngabe le function le mangi-differentiate iyanginikeza yini. Minginikeza lokho, it should be this function raised to that power there. Okay.
Sebe sacela ungichaza kulesi sibalo sine-partial fraction labo so-eda khona u-2 usugeba lapho ku-integrate sani ukhiphe ngaphandle 1 over 2. Ngisalile ngiba ngisabona.
This is the partial fraction.
Yeah.
Ngebla ngikhiphe khona u-2 la.
Yebo. Estepini says 4 usuka ngaphandle.
Oh, 1 2 3 la angithi. La.
Yebo, la ku-integral sani ede khona u-2 wasukhipha u-1 u-minus 1 over 2 ngaphandle. Lesi singaphezu kwalesi.
Derivative. What is the derivative of 1 plus 2y? U2, angithi?
Yeah.
So I'm supposed to have a 2 on top here. So I compensated it ngawakho lo 2. Base ngibuye ngawudivide futhi ngo2.
Okay.
U-minus buvele ukhona. U-minus buvele. Yeah. That is what I'm doing even on the problems that we have right now. I'm compensating.
Okay.
Right. Any other question? On homogeneous, I mean on linear. Let me see if I can find one for you. We are writing on Monday, good people. You should be asking questions. I don't have it. Anyone who might have one? Right. Let's try this one. dy over dx minus 3y over x plus 1 is equals to x plus 1 to the power 4. To the power 4. Right? If you look at that one, is it? Yes.
Angazi noma inkathi lokuzama ukungena lana akuveli lutho esikhulumeni sami.
Kwabanye kuyavela.
Yes.
Ya mhlawumbe wena unenkinga ngalapho mntanami. Right. So let's try that one. So if you look at this one, is it linear differential? Yes, it should be linear. There is your dy dx. There is your y with a coefficient there. And there is your what? Your q. So your p here, be careful, there's a minus here. So your p, it's minus 3 over x plus 1. And your q is what? Is x plus 1 to the power 4. Right. Then You must find an integrating factor. So integrate P, integral of minus 3 dx over x plus 1 is equal to minus 3 in x plus 1, which is the same as in x plus 1 to the power minus 3. That is that, or if you like, you may as well leave that minus there. So this is just minus ln of x plus 1 what? Cubed, it doesn't matter. Then, what is your integrating factor? Your integrating factor, therefore, will be equals to what? Integrating factor is a to the power minus ln of x plus 1 to the power 3. That becomes a to the power ln of x plus 1 to the power minus 3. And your answer becomes what? X plus 1 to the power minus 3. Therefore, what is your general solution? General solution is y times if is equals to integral qx times if dx. Therefore, what is y? Y times x plus 1 to the power minus 3 is equals to integral q x plus 1 to the power 4 x plus 1 to the power minus 3 dx equals to, that is just ordinary algebra there, x plus 1 to the power 1 dx. Therefore, what do we have here? Can we integrate that? Yes. Derivative of that is 1. So your answer there is x plus 1 squared over 2 plus c equal to 1 y x plus that to the power minus 3. But take note that this is just x plus 1. This is y over x plus 1. Perhaps if I may write that, this is just y over x plus 1 cubed is x plus 1 squared over 2 plus c. Make y the subject of the formula by multiplying. So that will be x plus 1 to the power what? 5 over 2 plus what? C into x plus 1 what? X plus 1 cubed. That should be your answer. Okay. Let's try this one. dy over dx minus 2y over x is equal to 3x cubed. Right? If you work that one out, is it linear? Yes. What is your p? P is what? It's minus 2 over x. That coefficient of y, which is minus 2 over x. And what is q? Q is what? Is 3x cubed. Therefore, what is the integral of minus 2 over x dx, which is your p? Is equals to, that is the same as minus 2 integral dx over x. That is minus 2, what? Ln x, which is the same as what? Ln x to the power minus 2. What is then your if? Your if is a to the power the integral of p dx, which we've already worked out as ln x squared. And you know that the answer there is just x squared. Therefore, what is the general solution? General solution would be, general solution is y times x squared is equals to integral of 3x cubed and x squared dx, which is just 3 integral x to the power 5 dx. Then what is your final answer? Y x squared is what? Is 3x to the power 6 over what? Over
Excuse
6.
me, sir.
Yes. Let's
It's
see.
a negative 2x to the power of negative 2, not x squared.
Wait. Here, ne? Yeah, here. Yeah, minus, ne? Yes, minus. Thanks. Then minus, yes, thanks. So this is not correct. So it should be what? 3 what? 3x, ne? That and that give us x. So, and that is not correct. So I'll get y times x to the power minus 2 is equals to what? 3 integral what? X dx. Yes. That gives us 3x squared over 2 plus c. Finally, don't forget that x to the power minus 2 is y over just x squared is 3x squared over 2 plus c. That is what is y. Y multiply, that is 3x to the power 4 over 2 plus what? Cx squared. This is your answer. Thank you. Okay. Perhaps we move on to the next set of DEs that I talked about. Mind you, did you get the message that your test is not going to be multiple choice? Okay, just an ordinary test. Okay.
Yes.
Next, DEs that were exact.
Sorry,
This is
sir.
yes.
Khona ngicela ungenzele sona futhi khona la kuma linear.
Yeah, say sure.
Sithi dy over dx
dy over dx
equal to
yes
5e
5e right
exponent cos x
yes
minus y cot x.
okay
Bese kuba ne-condition ethi y into pi over 2 is equal
minus
to
4.
minus 4, yeah.
Okay. I think I did this in class, but it doesn't matter. Let us see whether it is linear. General form. dy dx, take the term with y on the other side, plus y cot x, leave 5e cos x. Now, if you look at this structure here, it is similar to all linear DEs. So what is your P? Identify your P. Your P is cot x. What is your Q? Your Q is 5e cos x. Right? Having noticed that, then find the integral of P. The integral of cot x dx is equal to cot is what? Is cos x over what? Over sine x dx. That is cot, because tan is sine over cos. So cot is the reciprocal of that. As before, denominator is sine x. Differentiate sine x gives me cos x direct. So the answer is being what? Sine x. Therefore, what is my integrating factor? My integrating factor is a to the power of the integral of p dx. It's a in sine x, which is what? Which is sine x. Therefore, once you have obtained your IF, find the solution. All linear DEs will be y times integrating factor. Sine x, general here solution. Sine x is equal to integral of 5 constant, e cos x, what? Sine x dx. Can we integrate this? Yes, remember, next one, 30. integral f prime x e to the power f at x dx. The answer is given by e to the power f at x plus what? Plus c. Which means that if you take this f at x or index ka e, u differentiate fanele ngithole le yanto. Uma ngiyithola le yanto, the answer is given by e to that f at x. Asibhekeni lana. Now, nayi derivative nangu f at x wami low cos x. Differentiate it. What is the derivative? Ungawufaki inkaso differentiate. What is the derivative of cos x? It's minus sign. Oh, I do have sign. Engenayo minus. Then I can compensate that. Then ngifuna minus, perhaps rewrite it as minus sin x e power cos x dx. Why ngifaka minus? Because the derivative yaleyanto inikeza minus sign ebengenayo. But I've multiplied by minus, I must also take minus out. Kuze kufane. Then y what? Y sin x. Uma kunjena sekulungileke manje. Lento isiyilento manje exactly. And the answer is what? What is outside? Then e to the power what? To the power cos x plus what? Plus c. That gives me y sin x. But what are we given? We are given that what? But y is minus 4 ngalesikhathi x obani pi over 2. Must find c. This implies that we substitute y, it's minus 4. There is sine pi over 2 equals to minus 5 e cos pi over 2 plus c. Pi over 2 is 90. Sine of 90 is 1, so that becomes minus 4. Minus 5. Pi over 2 is 90. Cos of 90 is what? It's 0. E to the power 0 plus c. Any number to 0 power, it's just 1. So it's minus 5 plus what? C. Solve for c. Therefore, c is 1. If you solve for c there. Hence, what is your equation? What is your final answer? Therefore, hence, your solution is y sin x minus 5e cos x plus c, but now my c is 1. That is your answer. Okay. Are you happy there?
Yes, sir.
Sure. The next type of D is that we looked at where D is that were exact. That should be relatively easy then. Exact D is. Format. All exact D's will take this shape. F made up of x and y, dx plus g made up of x and y, dy always equal to 0. We say D is said to be exact. DE is said to be exact. If and only if what? Partial derivative of f with respect to y. Now your f1, but you differentiate partial with respect to y must be equal to partial derivative of g with respect to x. So D is said to be exact if that is the case, if that happens. So the D is said to be exact. Right? And the solution is obtained by solving one partial integral of f x y partially with respect to x. And we will get some function f at x y as psi of what? Of what? Of phi. Remember, I psi and phi. 2 integral g x y partial with respect to y will give you g x and y plus phi of what? Of x. Then combine the two. If you combine 1 and 2, combine, you will get f, x and y, g, x and y, plus psi, plus phi, all those being what? Constant. An example or examples. 1. Solve the following exact differential equation. It's 4x cubed y cubed minus 2xy dx plus 3x to the power 4 y squared minus x squared dy equal to 0. The d appears to be exact, but we must show whether it is indeed exact. Remember what I've said above. Condition for exactness, d is said to be exact if this holds. If this holds. F, you differentiate with respect to y, yet got given by dx here. G, you differentiate with respect to x. So that is what we must show first. So which one is my f part? My f part is this term here. This is f. So what is solution? What is partial of f, which is 4x cubed y cubed minus 2xy with respect to what? With respect to y partially. We differentiate that. Derivative, now which one is a constant? The whole of that is a constant. Derivative of y cubed is 3y squared. Bring back 3 and 4, that will be 12x cubed y squared minus. Same story here. 2x is a constant. Derivative there is minus 2x. And again, take your g term, which is this. We now dy. And partial derivative of what? Of 3x to the power 4 y squared minus x squared with respect to x. What is the answer? Differentiate with respect to x now. Derivative there, y squared is a constant. That will be 12x cubed y squared minus what? With respect to x, minus 2x. You can see that these two are the same, then the DE is exact. Now, we know now that the DE is exact. Can we solve it now? Yes. Therefore, to find its solution, therefore, it will be the integral of f now. 4x cubed y cubed minus 2xy partially with respect to what? To x now. So we integrate partially with respect to x. Y is a constant. So that one is a constant. That one is a constant. Yes.
So double is good testing. Good testing on my proof. What's it? Like my equation is exact.
It will depend on the question in 10. Coming 10, show that the D is exact. Then we have to go through that. Okay.
All right.
Yeah, integrate log. Gitatu 4 no y cubed out because I'm integrating with respect to x. Nalana foot tengenza. 2 no y. I'm integrating x partial with respect to itself. So it's 4y cubed bracket. What is the integral of x cubed? Is x to the power 4 over what? Over 4 minus 2y. What is the integral of x? Is x squared over 2. That gives me plus what? Plus phi of what? Of y was a constant. That is the same as y cubed x to the power 4 minus what? Y what? X squared plus phi of what? Of y. Right? I think that will make things simple for you. Then again, the g term. G term, my g term was what? 3x to the power 4 y squared minus x squared what? Partial with respect to y. The same procedure is above, but now with respect to y. which one is a constant? Is 3x to the power 4. So it's 3x to the power 4. But what is the integral of y squared? It is y cubed over what? Over 3 minus, with respect to y, that will be x squared as a constant. Integral of a constant is not 0. It will be the operator. Squared here, y, plus what? Plus what? Phi of what? Of x. This becomes what? X to the power 4 y cubed minus x squared y plus what? Phi of x. Therefore, combine the two integrals. Combine, but terms that are repeated, you only write it once. You'll see that I've got x to the power 4 y cubed. There is x to the power 4 y cubed. So it has to be there, but represented once, right? And then this, and again, is the same as that. So minus x squared y equals to phi of x plus psi of x is some constant, what, k. And this is your answer. Okay. Remember how to work it out. Solution is obtained by, this must be known, you must know that. Okay. Right? Perhaps another one. Let's try this one. Cos y plus y cos x, what? Dx plus sin x minus x sin y, what? Dy equal to 0. Is the d exact? Your dx, that's your f term. Dy, that's your g term. Condition? Partial of the f term. Cos y, cos x, with respect to what? With respect to y. What is that? What is the derivative of cos y with respect to y? It's minus sin y. What is with respect to x? Then x is, cos x is a constant. Derivative of y with respect to itself is just 1. So that becomes what? Cos x. I guess money derivative partial with respect to x of what? Of sin x minus x sin y. What are we going to get? Derivative here with respect to x to itself is what? Is cos x minus. Which one is a constant here? It's sin y, the whole of that. The whole of that. What is the derivative of x then? It's just minus 1. So bring back sin y. So it's sin y. If you look at these two, they are the same. There is minus sin y, sin y. Cos x, therefore dE is what? Is exact. Right. Now we are dealing with an exact dE. Can we solve it now? Can we solve it now? Yes. How do you find it? Then you say the integral of the f expression. My f expression was cos y plus y cos x. You integrate that partially now with respect to x. Double check, right? Differentiate with respect to x. Now, if you integrate with respect to x, integral of cos y. Now, this y is a constant because y is a constant according to that. So take it out. When you integrate something with respect to x, it means you are integrating just dx, which is x. And with what you have taken out, so is x what? Cos y. Plus, if it is plus. With respect to x, y is a constant outside y. What is the integral of cos x? Partially is what? It's sin x. So it's y what? Sin x plus phi of what? Of y. Y was a constant there. Next, integral of what? Of the next one, which is sin x minus x sin y, partially with respect to y. We integrate with respect to y now. Which one is a constant? This one is a constant, but we are integrating, just like integrating dy, which is y. So that is going to be what? Y sin x. And with respect to y, this one out of the integral side, what is the integral of sin y? Is negative cos y. So it's negative cos y with that negative, so it becomes what? Plus what? X what? Cos y. Plus what? Plus phi of what? Of x. Combine, therefore solution will be terms repeated. This is the same as that, so you write it only once, cos y. This is the same like that, so it's y sine x is equal to some constant p. This is the answer. Okay. Okay, so far so good. Right. The last one will be simple, operator D. There's nothing much more based on the scope. Operator D. D and 1 over D. Leave out the theorems. Remember, 1 over D means integrate, yet D means what? Differentiate. Okay, now remember the expansion that I gave you. 1 plus D to the power minus 1 equals what? Equals 1 minus D plus D squared minus dot. 2, 1 minus D all to the power minus 1 equal to 1. All terms here are positive. If for whatever reason we don't have something like this, we use our binomial expansion. That is A plus B to the power n is what? It's A n, more especially when n is not minus 1. A to the power n, A to the power n minus 1 times B plus what? N into n minus 1, A to the power n minus 1, what? B squared all over what? All over 2 factorial. Sorry, just to be 2 there. Plus, the next term is built from the previous one. N minus 1, n minus 2, A, n minus 3, B cubed, all over 3 factorial, plus dot. I'll ask a question that will require you to expand something. As an example. As an example here, I can ask you to expand, evaluate. I have a class at 4:30. I'm rushing now. I can ask you to evaluate 1 over D cubed into what? 3x squared plus sine 2x. What is the meaning of that? It means you integrate it how many times? 3 times. Okay, we can do it by inspection. Let's integrate. I think our math is okay now. But for the first time, what is the integral of 3x squared? It will be x cubed. That is the first time. Once more, what is the integral of x cubed? It is x to the power 4 over 4. And once more, what is the integral of x to the power 4 over 4? Is x to the power 5 over 20. So that is x to the power 5 over 20. Then integrate this one 3 times again. For the first time, it's integral of sine 2x. It's minus cos 2x over 2. Once more, minus sine 2x over 4. Once more, plus what? Cos, ne? Cos 2x over 8, if I'm not mistaken. That is that. That is your answer. And again, I can ask you to evaluate 1 over d squared plus 2d acting on what? On x squared. Now, start from the known to the unknown. So 1 over d is common here because 1 over d is known. Then here we are having what? D plus what? Plus 2 acting on what? On x squared. I think I did this one again. Well, this I know, 1 over d. The problem is it's 1 over d plus 2. Mina engikwaziyo kahle ikuphi na? Ilokhu. Oku 1 plus d to the power minus 1. No, it's easy then. I can take what here 2 as a common factor. Take it out. No d over 2 plus 1 on what? On x squared, which I can rewrite it as 1 over d, leave that one. In fact, 2d, if I multiply it by that, 1 over what? 1 plus d over 2 on what? On x squared. Next, that becomes 1 over 2d. Now, this I know now that it's 1 plus d over 2, index minus 1, on what? On x squared. That gives me 1 over 2d. What is the expansion now? Now, this expansion is similar to the expansion that I know precisely. Similar to that. Just that this d now, in my case, is d over 2. But the terms will be the same. So, terms, first term, it's 1. It's plus, so they will alternate. D over 2 as my next d. The next one is plus d over 2 all squared. I'll stop here because this is raised to the power 2. On what? On x squared. That gives me 1 over 2d into, let us multiply 1 times that is x squared, minus derivative of x squared is 2x, so that is 2x over 2. Second derivative of 2x is what? It's 2, so that it becomes 2 over 4, because that is over 2 over 4 there. That gives us 1 over 2d into x squared minus what? X plus what? Plus half. Then 1 over 2. Then what is 1 over d? It means integrate. What is the integral of x squared? The integral of x squared will be x cubed over 3. Integral of x is x squared over 2. Integral of a constant with respect to x is x over 2. And this is your final answer. Okay, as simple as that. These are the type of questions that you must expect on Monday. And may I just stop here? I have a class at 4:30 again.